Hello, welcome to the video. In this lesson, we're going to be looking at section 2.6, where we're going to be solving absolute value inequalities. Absolute value inequalities are essentially, we are solving compound inequalities. The only thing that we have to be able to figure out is our absolute value inequality example the and statement like we did in 2.5, or are we looking at the or statement like we did in 2.5? The graphs would be the same. The way we write them will be exactly the same. We just have to be able to figure out which statement are we looking at with a particular situation. So here is sort of the guidelines. The first thing that we have to keep in mind is when you have an absolute value inequality is we must isolate that absolute value. So if there's anything on the outside of the absolute value, like for instance, like they're using ax plus b that's inside there in this example, but if there was like a plus d or it was multiplied by f and you had an inequality like that was greater than c, you'd have to take care of all of those things here. So you'd have to like subtract d to both sides, divide f to both sides there. You'd have to do all of those things in order to isolate the absolute value. Once you have taken care of all of that stuff, then you have to say, okay, is the value that you got, in this case c, is it greater than 0? If it is, we can move forward. If it's not, all you have to do is say, okay, is the statement true? If this is a negative number, and the inequality is pointed towards that negative number, it's going to be no solution. Why? Because everything that we're going to get that's inside that absolute value will be positive. So it doesn't matter what value we get inside that absolute value, whether it's positive or it's negative, the result of it's always going to be positive. So if I always get a positive number, it's not going to be less than a negative number. So that's where we get the no solution. If it's greater than, so it's pointing towards the absolute value, that's where we get the infinitely many solutions. So we have to keep that in mind. So if it's positive, we can move forward in this. If it's negative, we have to say, okay, is it a true statement or a false statement, and go from there. If we have a positive number, which that's what they're asking us, and the inequality is pointing towards that constant value of c, that means we are going to treat this absolute value inequality as the and statement. And then this is how it would be written. The first part is it would be whatever's inside the absolute value. In this case, ax plus b would be greater than negative c, and what's inside that absolute value, the ax plus b, would also be less than positive c. If you were to write this as a condensed form, you would put negative c on the left, you'd put positive c on the right. Remember, just like what you did in 2.5 with and statements, the inequalities are both pointing towards the right, and what would be left inside would be ax plus b. So that would be our condensed version of the and statement. If we had a situation here where the absolute value, the inequality is pointing towards the absolute value, now we're treating it like an or statement. And it's going to be written as follows. ax plus b is less than negative c, or ax plus b is greater than c. Again, it's not common practice to write it as condensed form, but this is what it would look like. So you would have negative C here, positive C here, and the inequalities would be pointing towards the left. And then we would have inside would be AX plus B. If you notice, with this particular point of the situation, the inequality is pointed towards the negative C. It is there. If you look over in this part of the situation, the inequality is pointed towards the AX plus B. It's consistent. It's just how it is written. And it works for both uh, the less than or equal to and greater than or equal to. It's also going to be graphed the same as it was in 2.5, whether it's an and statement or if it was an or statement. Okay. All right. So here they are asking us to solve each inequality, and they want us to graph each solution if possible. So here is example A. I got the absolute value of x plus 7 is less than or equal to 2. So we have nothing else on the left-hand side. We just have the absolute value. Now we have to ask ourselves, all right, is that constant value or the value on the outside positive? The answer is yes. So we can go about solving it. What that means is because the inequality is a less than or equal to, we're going to treat this as an and statement. So here, I'm going to write in my x plus 7. This is going to be my less than or equal to. It's still going to be less than or equal to. On the left is going to be a negative 2, and on the right it's going to be a positive 2 because it was, remember, it was opposite of C and then it was the value of C on the right. From here, I am going to subtract 7 in all three sides. So when I subtract 7 here, that gets canceled. When I take negative 2 minus 7, I get negative 9. I got less than or equal to x, which is less than or equal to a negative 5. So solving this particular and statement now is x must be between negative 9 and negative 5. So if I were to graph this, just like you graph any and statement, so I got my negative 9, I got my negative 5, both are closed circles in this situation, and because it's an and statement, the shading is in between. For B, I have absolute value of 8x minus 11 is less than 0, okay? So here's the situation. If you recall, the stipulation was that C must be greater than 0. It doesn't say anything about equal to. So what this means in this particular instance is I can't solve this inequality because there's no value here that I could get that would be 0, because if I could get a value here, I could get 0, but the problem is there's no equal to sign. So what we have to now ask ourselves, is this a true statement or is this a false statement? Is there any value that if I get any value here, I get 0? Well, is 0 less than 0? The answer is no. If I get any negative number, doesn't matter, I'm going to get a positive value. So is any positive number less than 0? The answer is no. So this particular situation, I can't solve it, and there's no true statement, so I get all false statements. So since I get all false statements, this is a situation where I get no solution. So in example 1, we have the absolute value of x is less than or equal to 3.5. Nothing we have to do on the outside, so I leave it as x. And this one is being treated as an and statement. So this is 3.5 over here, and this is negative 3.5 over here. Since there's nothing else left to do, this is actually your answer. So I got negative 3.5. I got positive 3.5. They're both closed circles. And my and statement is written here. For number 2, C right off the bat is a negative number. So, and the inequality is pointed towards that negative number, which means there's no value that I'm going to get that's going to make this a true statement. So this is no solution. For number 3, it's a positive number with 11. And we got all, so I'm going to write 2w minus 1 is less than 11. And I got this less than, it's going to be negative 11 on the left-hand side. So add 1, so not only do I add 1 here, but I add 1 over here. So that gets canceled. So I'm left with 2w in the middle. 11 plus 1 is 12. Negative 11 plus 1 is negative 10. Now I'm going to divide 2 to all 3 sides. This is going to be now w. This is less than still. This is now going to be 6. 12 divided by 2 is 6. Negative 5 divided by 2 is, no, negative 10 divided by 2 is negative 5. So here is my and statement from the absolute value inequality. I got my negative 5. I got my 6. They're both open circles, and the shading's in between them. If you look at these examples, let's take a look at A. So A, there is no change here, and it's positive 5, so I can go about solving this. So because the inequality is pointed towards the absolute value, we're going to treat this like an OR statement. So now I have C minus 1, and now it's going to be greater than or equal to 5, and it's going to be greater than or equal on the other side, and it's going to be negative 5 on the left. So I like to solve both and OR statements in condensed form. Can you expand the OR statement? Absolutely. Absolutely you can. And go about and solving it from there. So adding 1, I get C. This is greater than or equal to 6. I got greater, so negative 4 greater than or equal to C. If you left it like this, that's fine. If you want to do it in more common form, the expanded form for an OR statement, you would rewrite this as C is less than or equal to negative 4. The inequality is pointed towards negative 4. In the condensed form, still over here. Or C is greater than or equal to 6. All right, that's more often than not how you're going to see it in answer keys. And to graph it, I got negative 4. I got 6. They're both closed circles. And because they're OR statements, the shading is on the outside. Okay. If you look at B, we have a negative number here. And we're looking at the absolute values pointed towards the inequalities point towards the absolute value. So that means that, every number that we're going to get is positive, and even also 0. So 0 is greater than or equal to negative 2. So we're going to get all true statements here. And since we're going to get all true statements, we're going to get infinitely many solutions or all real numbers. And if we were to graph this, you would just simply shade every value in the number line. Looking at C, C is where we have some more stuff that we have to take care of on the left-hand side because that absolute value is not isolated. So I'm going to subtract 1 first. So now I have 4 times it by the absolute value of 2x minus 5 is now greater than 20. Divide 4 from both sides. I now get the absolute value of 2x minus 5 is now greater than 5. So now that I have that, 5 is a positive number. The inequality is pointed towards the absolute value, so we're treating this like an OR statement. So 2x minus 5 is in the middle. This is greater than 5. This is still going to be greater than, but negative 5 is going to be on the left-hand side. So all of this comes into play. Add 5 to all 3 sides. So this gets canceled. This becomes 0. So this is 0 is greater than 2x, which is greater than 10. I divide 2 both sides. So this becomes 0 is greater than x, which is greater than 5. So if you left it like that, that's okay. But if you rewrite it in expanded form, it should be x is less than 0 or x is greater than 5. And if you were to graph this, I got my 0, I got 5. They're open circles, and the shading should be on the outside. And it is consistent with the arrow because our variables are in fact on the left-hand side. And that is being able to solve absolute value inequalities. Hope this helps. Till next time.